Hello, everyone, and welcome to our final webinar on the BigPanda agentic IT operations platform. We have saved the best for last, as today we'll be covering the IT Knowledge Graph. This is the foundation on which our platform is built and allows BigPanda to transform manual and reactive processes into intelligence autonomous systems for ITOps and ITSM teams. Before we get started, though, I do just want to cover a couple quick housekeeping items. First of all, check out the tabs with the resources at the bottom of the screen. If you do have a question throughout, please submit it in that tab, and we will certainly get to address your question after the fact. This is going to be recorded, so you will have an on-demand version that you can send to everyone that you'd like after the webinar, and you can also rewatch it yourselves. We'll also be following up with an email with this recording as well. But without further ado, let's kick off this webinar. I'm going to hand it over to Fred Koopmans, who you see here. He's our Chief Product Officer here at BigPanda. Fred, over to you.
Thank you, Katie. Appreciate that. And thank you to our audience for joining us. As Katie mentioned, this is our fourth and final installment of this webinar series focused on BigPanda's agentic IT operations platform. Quick rewind. First up, you heard Assaf Resnick, our CEO, present our vision for agentic IT operations. Second installment focused on automating L1 operations with our AI detection and response capabilities. That was led by Russ Elsner. Third was Travis Carlson presenting how we supercharge incident management and we predict and prevent incidents with Biggie, our AI incident assistant and AI incident prevention products. Now, today we're going to focus, as Katie mentioned, on sort of the last bit, but also kind of the linchpin to the whole thing. So that's for last. That's BigPanda's IT Knowledge Graph. We're going to talk about what it is, how it adds value, how it's different from other systems that sound kind of similar out there in the market, and the organizational impact that it has as well, and how it really helps transform operations teams to work in a AI-first mentality. So let's dive in. Quick reminder of a couple of things you've already seen, but just want to kind of bring these visuals back to you. This is BigPanda's platform. This is how we view agentic IT operations. Lots of individual data sources coming together to form this IT knowledge graph. Up until now, we haven't talked too much about that, but we're going to go into it in a second. Importantly, though, there are multiple applications that run on top of that knowledge graph. So this is an asset, something that you build and maintain and curate, and it pays dividends across multiple different ROIs or value propositions. So, we use it to power our AI detection and response, where we automate L1 operations. We use it to supercharge incident management. We use it to predict and prevent incidents. So that's the high level kind of reminder of the platform. And just to put an extra fine point on things, why do enterprises need such a platform? So as mentioned here, to automate L1 operations, to supercharge incident management, predict and prevent issues, and organizationally, to bring all these different discrete teams, these fragmented, siloed teams, tools, and processes together. And that's where we're going to really dive in today. Now, as we do that, let's start with taking a quick look at the current state. How do IT operations teams work today? So we're going to walk through some kind of process/org chart that helps to depict that. We're actually going to start at the bottom of the slide here. And what you can see is two different L1 organizations. There's a team, the operations center, the NOC, the TOC, something like that over on the left. And then there's a separate team on the right, the service desk team. The NOC team is responding to signals coming out of their observability tool suite, whereas the service desk team is responding to signals coming from customers, via phone call or email or Slack or shoulder taps or kind of whatever. So you have these two different L1 teams responding to different signals. Their jobs, roughly speaking, are detect when something unusual is happening, dive in, conduct some lightweight diagnosis and triage. You know, is it really happening? What's the impact? Are other people seeing this? That kind of a thing. And then decide how to respond. And for an L1, the response is typically ignore it or pass it up the chain, you know, pass it on to some other organizations. These are the basic sort of L1 capabilities. It's a first line of defense. All of that then is sort of translated and documented into some sort of handover, a ticket, if you will, that then goes to higher up teams, L2s, L3s, SME organizations, you know, the network team, cloud team, et cetera. Now, the thing about those teams is they all have some other day job, typically. They have a strategic day job, and it's interrupting to them to be pulled into these sort of tickets and firefighting kind of investigations. That's why the L1 team exists, is to be the, you know, the front line there to defend that time. But those interruptions happen constantly. And when the L2 teams get those tickets, well, they have to dive in. They don't particularly trust the L1, so they have to verify the information that was given to them. They have to figure out what's really happening. And then, you know, when something's really broken, they have to figure out how to fix it. And in both cases, you know, that's really about information sharing. It's searching for and producing and synthesizing and analyzing IT knowledge and then communicating that, you know, L1 to L2, L2 to the leaders, architects and managers, et cetera. So this is sort of, you know, the picture of how information flows from the bottom towards the top through all these different systems. Now let's see what happens on a bad day. Okay, something's going wrong and multiple things start to go wrong at once. So if you've got a relatively mature observability deployment, the NOC's going to get flooded. It's not just going to be one alarm going off. There's going to be lots of alarms, an event storm, if you will. That's going to flood the NOC. Additionally, customers are pretty good at noticing when things are broken. So the service desk is going to get flooded too. And you've got these two different L1 organizations all of a sudden being inundated with information. They're trying to make sense of what's happening. They're each going to do some basic diagnostic and triage steps. They're each going to be reaching for their run books, trying to find their run books, executing the run books, spending time, valuable time during this emerging outage, looking for what's happening, what's wrong, what do we do about it? Have we seen it before? You know, did something change? It worked yesterday, what changed? This is what all the questions sort of floating through the minds of the L1 teams. And I'll point out that each of these two L1 teams are doing this without any information of the other team. The NOC doesn't know what's happening in the service desk, and service desk doesn't know that the NOC is being flooded with alerts at the same time. At some point, typically, they each kind of reach their SLAs, they kind of get overwhelmed, and they hand it off towards the more advanced teams. When it hits those advanced teams, everything kind of gets read all at once, right? This is how bridge calls from hell are born. Hey, a bunch of stuff's going on, call everybody. And you'll end up with, you know, 85 people on a phone call, all trying to figure out one at a time, does the network, is the database, the application, no, you know, very inefficient. Everyone's screaming, no one knows what's going on. Does this sound familiar? You know, hopefully not, but frankly, I haven't met an enterprise that doesn't experience a day like this on a pretty regular basis. And again, I'll kind of come back to this idea that like a lot of this is about, you know, the information collaboration component of it that I highlighted. Well, why does this happen? You know, three different reasons why we see this happening. First off, you've got these siloed teams that aren't communicating. You've got siloed data that is incomplete and inconsistent and stale. And that's a big part of the problem as well. Everyone's working on imperfect data. And you have a bunch of manual processes. These manual processes weren't designed for fast resolution at today's scale and velocity of the business. And that makes everything more slow, more expensive, more error prone, and that causes a number of negative business consequences. These are undeniable. You know, the world spends more than 200 billion just on L1 operations, you know, in total, not to include all the personnel costs associated with the tools and the L2s and the L3s and all the subject matter experts. the revenue impact of that chaotic environment and the brand reputation and the unhappy customers and unhappy employees, it all adds up. And well, this is the pain that BigPanda has dedicated our company's mission to solving. But let's kind of circle back to that data layer. And our view is that this is the pain that I just described is anchored in a failure of the data model. It's not that these teams are they're bad people or ineffective or they enjoy doing things slowly. Nothing like that at all. They're doing the best they can with the data model that they have. It's inaccurate, it's incomplete, it's fragmented, it's stale. You get conflicting data between different things. That's the reality that these teams are working with. And they're using that to power a bunch of manual processes. So if we want to make a significant, movement from the world I just described to a much more efficient, productive, faster, better world, we need to address this data model. And it needs to be suitable for powering AI workflows, not manual processes. Okay, so how do we do that? Well, we need a new data model. Agentic IT operations, everything we've been talking about with an automated L1 and automated incident management requires a new IT data model. If we think about the past, this was a data model centered in the CMDB. This was the center of the universe. It's a relatively small amount of data that has been collected through service discovery and service mapping and sort of manual curation. And it's limited to highly structured data. It's like form fills, tasks, tickets. It's kind of a small amount of data. And it's kind of like fundamentally, it's trying to describe the world as it ought to be. This is how my environment is supposed to look. And it sort of falsely assumes everything is nice and neat and well organized. That's sort of part of the problem. The other part of the problem is that it was designed for a different era of applications. It's designed for rules-based automation and manual human workflows or processes. Well, that's the old world. The new world needs to look much different. CMDB is just one of many sources. Structured data is only one of the kinds of data sources you can be using. You need to support unstructured data, semi-structured data. You need to augment that data model with much richer, much larger volume of data. Machine-generated data, AI sensing data, human-generated knowledge, all of that needs to come together to, well, frankly, kind of describe the world as it actually is. The real world is messy and complex and interrelated and dynamic and forever changing. And the data model needs to match that, right? And it needs to be designed also for AI-based automation and agentic workflows. If we look just a little bit more closely at the traditional IT data model, okay, I might have oversimplified it, but it kind of looks like this. It was designed decades ago. It's basically CMDB plus events, so very limited in scope, famously incomplete and stale. Never met a customer that has had a full CMDB or been happy with their CMD deployment. All right, they're all kind of like, yeah, if the CMD was up to date, then we'd be in good shape, but it's not. So it's famously incomplete, famously stale. Similarly, events are only covering like a small fraction of your environment. Our customers tell us that more than half of their incidents aren't detected from their observability. They're detected from their service desk first. So there's gaps in the observability data. And you have this sort of disconnect. CMDB tells you how the world is supposed to be. Observability tells you how it actually is. And all of that's just not that useful. Best case is you can power some rules-based automation, but that's kind of the limits of it. Agentic AI requires a new IT data model. It needs to be much more flexible and back into here. It needs to be much more flexible. It needs to be more diverse and dynamic. And conceptually, it needs to look more like the human brain than just a table of highly structured data. It's not a table of rows and columns. It needs to look kind of more like this. This is how we think the IT data model for agentic IT operations should look. And well, that's why we built the BigPanda IT Knowledge Graph. This is literally how the BigPanda IT Knowledge Graph has been built, brand new from the ground up as part of this overall platform. Now, let's dive in a little bit more deeply. What are these different layers? Well, first off, let me kind of point out sort of three different layers of data or different categories of data. First is highly structured data. Okay, this is seem to be in events, of course, but also changes topology, even other capabilities of your internal observability tools. It's this rich layer of structured data generated by all your different tools. We want to bring all that together and make it accessible from the IT knowledge graph. That's one. Two is it's a rich layer of knowledge. And this is generated differently by all of your operational teams and systems of records. So this is your ITSM tools, your change management tools, your collaboration tools, your postmortems, all of your, run books and SOPs and knowledge base articles, knowledge management tools, all kind of get folded into that. It's the second layer. And then the third layer. The third layer is novel, proprietary, new data types that are unlocked by AI sensing. So this is generated by BigPanda. This is a whole new innovative suite of data. Deploying an observability agent into the service desk to notify the operations team, operations center, when something's spiking on the service desk. External observability, kind of studying the status pages and social media to determine, what does the internet know that maybe the operational teams should know about. Agentic eyes on glass, studying dashboards and noticing when graphically something spikes or falls off a cliff, and then generating an alert based on that. So it's like one category of like detection and detecting new things that wasn't possible prior to AI. Another category, though, is tacit knowledge and inferred information and process mining that we can deduce from the conversations using generative AI. Again, not possible with classical machine learning algorithms, but it's possible today. So that's the third layer. So data, highly structured data, diverse sets of knowledge coming from a bunch of different sources, and then this AI sensing layer. And when you bring all of those things together, you have our IT knowledge graph. And that's what unlocks that collaboration that I was talking about. That's what helps you to start to unify those fragmented operational teams. Once you have shared data, they can start sharing, and it can be sort of an implicit collaboration. You don't have to tell team A and team B to communicate. You just give them shared data and they'll do it automatically. So you can get the NOC and the service desk working on shared data. Get the L1 team and the L2 teams working on shared data. The centralized IT teams and then the decentralized engineering and DevOps teams working on shared data. The network team, application team, and so on, right? This is kind of what we mean by unifying all these fragmented teams. Give them a robust, comprehensive, extensible knowledge graph, and they'll start collaborating automatically. And then if we kind of go back to that kind of org chart view, that IT knowledge graph forms the connective tissue across all of those silos, those siloed teams, tools, and data. And as you heard about in our other webinars, we're also, not for nothing, using this IT knowledge graph to power our agentic AI and automation capabilities, automating L1 operations, supercharging incident management, predicting and preventing incidents before they happen. And all of that together helps lead to better operations, to put it simply, faster resolution, lower personnel costs, happier customers, more revenue, happier employees, all of these things. Now, kind of painted that picture there. Before we kind of end the discussion here, let's take a close look at what really sets BigPanda's IT knowledge graph apart from others. And trust me, I'm fully aware that there are a lot of platforms out there, a lot of vendors that have a horizontal blue box that sounds like a data fabric or a knowledge graph or something like that. So, I'd be surprised if you don't have this question in your mind. How is ours different? Let me highlight 5 things. First off is this is not fundamentally built on top of a CMDB. And so no CMDB required, no service mapping required. By the way, those things are helpful, right? If you have, good data in yours, great. The more the better. It helps us get started. We'll take the structured information, but it's not a prereq to get going. We can infer a lot of these relationships by studying the event stream and studying the operational history. So it gives you a massive head start and helps fill in all of the gaps that the CMDB is then held back by. In fact, a lot of our customers have started to use the IT Knowledge Graph to improve the CMDB and add updates and fill in those gaps. So that's one thing. Second thing is this is not another replica of your data. I know many of you might be thinking well, I don't need more copies of all of my operational data floating around out there. That's not how this knowledge graph works. We're not storing a copy of all your data by any means. 2 things. First off, we are proactively pushing some of the data into BigPanda, only what we need, and we index that data at ingest and only store the insights that are useful for us. And we discard the rest, right? So that sort of limits the exposure and the data volumes associated with that. So that's one thing. The other thing is when necessary, we'll go pull live data on demand. So we don't have to push everything in proactively. We don't need to push all the metrics, logs, traces, errors into BigPanda. We'll pull those agentically when we need them. Those errors into BigPanda. The knowledge graph is not only what do I know, but where do I also know where to go get information about certain things? So I'm going to go to PagerDuty to get information about this, or Datadog to get information about that. That's part of this knowledge graph here. It's very different than a classic kind of database architecture. Third is this is not another walled garden. In fact, quite the opposite. The point of this thing is to provide connectivity across all of your different teams and tools. The observability walled gardens that we see sort of merging by these large observability vendors, the ITSM and ITOM walled gardens that are kind of emerging kind of on the other side of things, even developer knowledge stores and walled gardens. This breaks down those walls and connects them all together. And that's what unlocks the knowledge sharing and collaboration across all of those teams. So that's the third thing. The fourth thing is there's unique data types in here. The novel AI sensing, these new forms of observability, agentic eyes on glass, service desk observability, external observability. These are all kind of unique, invented by BigPanda data types. The tacit knowledge, listening to a bridge call and recording the insights that oftentimes are the key of this service depends on that application, depends on that network. It was never written down anywhere, but they're mentioned through in moments of investigation, and we can mine all of that data and curate all of that data. We literally have customers that are sort of transcribing their thoughts, providing a brain dump informally to BigPanda's AI, and then feeding that and programming that into the knowledge fabric. That's really important, because one thing we all know about operations is that not every employee stays forever. And when they walk out the door, you want to be in a scenario where not all of their wisdom and knowledge about the interworkings of your services and business critical applications walks out with them. So it's important to have something strategically mining this tacit knowledge and curating it and preserving it and democratizing it out to all of your future operations people. So another big sort of component. Last but not least is that the IT knowledge graph from BigPanda is purpose-built for agentic IT operations. This isn't for developers. It's not for HR, for legal, or some sort of big, broad company-wide initiatives. It's for agentic IT operations. It's purpose-built. The data types we bring together, that structured data, that operational knowledge, and the AI sensing, is really designed to give us the breadth and depth for our advanced correlation and AI algorithms, right? We're trying to automate L1, we need certain data types to power that. We're trying to supercharge incident management during a critical outage, we need certain data types for that. That's one. And then two is we operate at machine scale, right? This isn't an older sort of architecture that has database sort of scalability limitations like some of the other vendors out there. This is a modern data structure, modern architecture operating for machine scale data. And it's designed for AI workflows. So we've designed this in a way where it automatically plugs into our algorithms such that as the knowledge graph expands and curates, it automatically enhances the intelligence coming out of our application layer. So we really see it as an operational intelligence layer that delivers tangible results and measurable value from agentic AI. We don't see anything else like it in the market. And like I said, it's fundamental to everything that we do. So with that, I'll kind of zoom back out and say, hey, the vision for BigPanda here, as I said, it's really anchored in this new data model. The IT knowledge graph is the key to automating L1 operations, supercharging incident management, predicting and preventing issues, and organizationally bringing those fragmented ops teams together. And it uses that with that shared intelligence layer. So with that, thank you for joining us in this series, and I will hand it back to Katie.
Awesome. Thank you, Fred. Appreciate it. I think that was a really interesting under the hood view, if you will, of the IT knowledge graph. Not only what does it entail, why did we build it this way, and what it can deliver for our viewers here. And I think, as you just were saying, I think it's a really interesting way to see how, really clear way to see how we're turning AI, which is, this kind of potentially abstract concept for folks, into this very tangible layer of operational intelligence that their ITOps and ITSM teams can use to really understand these complex dynamic relationships that are happening with their infrastructure. So really interesting. I hope everyone joining today found that to be insightful as well. So thank you. We appreciate your time, both Fred and everyone who has attended today. As I noted earlier, this webinar will be available on demand, so you can certainly share it out with other folks in your organization, and you will get a link in your email, or you can come back to this same link and you'll find this on-demand version. And if you would like to learn more about IT Knowledge Graph or the BigPanda Agentic IT Operations Platform, head to our website and we can set up a demo. But with that, thank you everyone and take care. Bye-bye.
Thanks.